All right, we're at 2:14. I think we're going to go ahead and get started. Thank you for everyone in the room that's attending, and I think there are some guests outside of the Port Angeles School District. Thank you for coming out. My name is Martin Brewer, the superintendent with the Port Angeles School District, and it's my pleasure to introduce Dr. Mike Maxwell of the North Olympic Healthcare Network. And before he gets started today, I just want to publicly thank Dr. Maxwell for one, doing this, but number two, for the Port Angeles community and beyond. The NOHN clinic led by Dr. Maxwell has really spearheaded the efforts to vaccinate in our community. At each of our mass vaccination events, the NOHN clinic is there helping, or actually leading that work with county officials. So Mike has been a critical part of that, and thank you very much, Dr. Maxwell, for leading that effort. How this is going to kind of flow today is Dr. Maxwell has a few slides that he'll go through, approximately 15 minutes in length. And then the moderator, Carmen Geyer, which is a communications specialist for the Port Angeles School District, will ask questions that we have received by way of two mediums. One, you can send an email to Carmen or Jenny, or number two, the Q&A button down below, you can type your question there. And if you would like to remain anonymous, my understanding is there is a small box under where you type, and you can click anonymous, and that will come to Carmen, and she'll read her question for you. If your question is not answered to your satisfaction, please type it in again, and we'll, or additional information, and we'll ask that question once again. So thank you very much for attending, and I'm going to turn it over to Dr. Maxwell. Thank you.
Great, thanks, Superintendent Brewer. We're very excited with vaccines getting deployed. That I tell my staff that we've turned the corner, but we found that the road goes uphill. So there's still a fair amount of work to do, but we're going the right direction anyway. And it was just for many of you that are on this call, like my patients, that vaccination is really, I understand, it's a leap of faith. Particularly if you're not coming from a science background, it could just it seems sort of mysterious, and there's a lot of vaccine hesitancy that sort of revolves around just misunderstandings and misconceptions, or just lack of knowledge about what they really are. And so I found in my practice that more information and the right information is always better. And I'm sure as educators that you totally get that. And so I found that people generally make the right decisions when they're given all the information and the right information. So Superintendent Brewer wanted to give us the opportunity to ask questions for you, ask questions of me to help give you more information and help you with your decision making. I prepared some slides just to introductory. There are some slides which get kind of sciencey and sort of kind of a little more into the biology behind it. And I don't know if that's of interest. I could spend weeks on this, but I'll try and hit it high level and quickly, just so there's concepts. In case when I answer your questions, if I refer to some concept, at least we have a common baseline anyway. So I'll go and start sharing my screen here. Always a crapshoot. People seeing it, the screen says COVID-19, hopefully.
Yeah, I can see your PowerPoint within. Yep, perfect.
Great. I think I need to. Does that look right to you? Is that the presenter?
It looks like it's a little distorted, a little bit, but it might work.
You see mostly white or mostly black?
It's mostly white, and it says COVID-19 vaccination in the upper right-hand corner.
Okay. You see, let me say myths?
Yeah, it says myths, false in the top middle.
Okay. Great. So I think we're on the right page. So hopefully you can see this all okay. So just to hit some things that I've run into my patients that many of you may have heard or carry some heard these myths, and they are. I just want to start with those because these are actually not true. That vaccines weaken the immune system. That is not true. And I can give the science behind why that's the case. Vaccines do not contain microchips. Bill Gates has nothing to do with putting microchips in people's bodies. Some of my patients have had those concerns.
Dr. Maxwell, I apologize. We're having a hard time hearing you as well. Yeah.
Sure. I have to apologize. I tend to talk fast. That's one of my many faults. So stop me anytime.
Great.
That any better?
Yeah, that is better. Thank you.
Great. Vaccines don't cause cancer or autism. It's been, again, disproven many times. There's a myth that vaccines make you infectious, that you can get people sick after you get the vaccine because it makes you exude the infectious agent. That is not true. That somehow the newer vaccines change your genetic makeup. That is not true. And that the vaccines were not tested sufficiently and that aren't proven safe. And that is untrue. There's a lot out there in the media about the speed with which these vaccines have been developed and that the implications that there were corners cut to rush them into the market before they are ready. In fact, there's a bunch of reasons why this was so successful. This was so speedy. It's not because the corners were cut. It's actually more of a testament to all the red tape, which happens with most vaccines, and red tape that was unnecessary was removed to really make it the most streamlined way to get a vaccine out there. An important part that I reinforce to my patients is that typically with a vaccine, when you're developing one, you develop it on a small scale, and then you test it, and then if it's proven safe, then you spend the next year manufacturing it to get it out to people. Well, they turned that upside down this time, and the federal government told the manufacturers, any of them, that they will fund dozens of different manufacturers to try and develop a vaccine and produce it simultaneously. And if it's not effective, they still got paid. So there was no disincentive to them manufacturing this ahead of time. So when we have these vaccines that have been proven to be effective, they already have large supplies that are ready to ship immediately. And that was the biggest thing, which sped up the availability this time around. So it's an important distinction. Some important truths about the vaccines. The duration of immunity of the COVID-19 vaccine is not known. We just don't know yet because it's only time will tell. And but all indications are that it is at least 3 months, probably longer, and maybe in perpetuity, but only time will tell. Vaccines will cause, for many people, a couple days of some side effects: muscle aches, fever, fatigue, headaches. It's just sort of feel kind of crummy for a couple days. And that is not a sign of infection. Many people mistake that for an infection, but it's not. It's a sign of an immune response, a recognition that something foreign was introduced to the body, and it is appropriately trying to fight that off and develop immunity against it. And many people will feel a little bit ill for a few days. The long-term effects of the vaccine aren't really known. I mean, it's by definition, if it's new, we don't know what's going to happen downstream. However, that does not mean we don't know anything about the vaccine. So I like to use the analogy for my patients. Tesla was a new car. It was a whole new model, whole new car that got put on the market. You did not hear people saying, "I don't want to drive that car because it hasn't been out before, because we don't know anything about it." Most of them said, I can't afford it, but that's not the reason people weren't getting Teslas. It wasn't out of fear that it was a new car. The longer it's on the road, we know more about the mileage, real life use, maintenance, and so forth. And you learn those things over time. But it's still a car, and there's some things that we can predict with reasonable accuracy about what we can expect from it. Same thing goes with these newer vaccines. These new vaccines are highly effective at preventing serious infection from the coronavirus. Any of these vaccines available are very effective at preventing death and serious infection. Even the Johnson & Johnson vaccine, which is only 1 dose. Masking and distancing still is required after you get a vaccine. But that's until a high enough proportion of the population is actually immune, and we've achieved herd immunity. However, it's also true that if you are fully immunized, you can gather with people who are also fully immunized without having to get masking or distancing. So there is a real side benefit immediately for you to be able to sort of have your bubble of immunized people be able to connect with as you used to. So I'm trying to be mindful of time, Carmen. I do have, so I've got, I guess, about 6 minutes into this. I'll dive into, hopefully quickly, but not so quickly that I blow past you, a little bit of the science. There are some basic concepts I think it's helpful for people to understand when you hear these terms. So you'll hear about antigen. That's an antigen is always a protein, and that's an important thing about immunity, whether it's allergies or regular immunity. We're reacting to a protein. Those we can't be immunized or allergic against vitamins or sugars, those kinds of things. It always has to be a protein. That comes important later. That stimulates an immune response. That's what an antigen is. An antibody is also a protein. It's a customized protein that called immunoglobulin that is made by our immune cells called B lymphocytes. And they are custom made to attach to that antigen protein one-on-one to trigger these other immune cells called T lymphocytes to destroy it. And it's a fascinating, it's just so cool it happens. And the science behind it is great. But so we're really talking about protein interactions. We're talking about the immune system. So as I said, an antigen is a protein. And this is sort of a representative picture of what a protein looks like, a protein. Proteins are long strings of amino acids that are strung together. And when they are constructed, they fold up into these very specialized shapes, three-dimensional shapes. And every cell in our body is covered and filled with proteins. Every infectious agent is covered and filled with proteins that are very specific to them. It's important to know that proteins do not cause infection. Proteins are not the infectious agent. They are no more than a spark plug is a car. So just because you have a spark plug does not mean you can drive a car. You don't have a car to drive. Just because you have a protein does not mean you have an infectious agent. So it's an important concept. So these are the cells that make those that make the antibodies, those other specialized proteins that we have, and they are made inside the nucleus. So those of you on the call who are science teachers, this is all, you probably know this, but it's worth reviewing. This is a very busy slide coming up, but this is just a little graphic of what happens inside the cell. So you have inside the nucleus is the DNA, which is the master code, which all DNA codes for is proteins. It tells our bodies how to make proteins. That's all DNA does. And it does that through a little messenger, a little piece of other instructions called messenger RNA that go to this little factory in the cytoplasm called the ribosome, which then translates those instructions to the RNA into a protein. And in the case of the lymphocytes, into antibody proteins. They're very custom and specific. So these proteins look like this. This is what a typical antibody looks like. It has this very unique structure. If we look at sort of a graphic representation of that in three dimensions, that's what it looks like, these molecules, and it kind of looks like a Y. And so you'll often see that graphics of antibodies show them as little Ys as representations, because that's kind of what they look like in real life. So when we get an infection, by bacteria or a virus, they're covered with proteins, which are antigens. They are foreign to us. And those are detected by B lymphocytes, and we start making little antibodies that attach to those viruses or bacteria, and it helps these other cells called T lymphocytes detect them and get rid of them. That's how it works, our immune system. Now, you've heard about coronavirus. Everyone's heard of the spike proteins. So this is a coronavirus. It's what's called an RNA virus. That means that inside of it has its own RNA, which helps give some instructions, a little segment of that, on how to make these spike proteins. Those spike proteins are on the surface of the cell. They do not cause infection, but they are one of the ways that the cell, that the virus attaches to us. And it's very unique, and it's what our immune system uses to say, this doesn't belong here. So when we talk about vaccines, it's really a very simple concept. We're trying to present our immune system with some advanced information, advanced awareness of what these foreign antigens look like. the antigen itself is not infectious. So if you give it to our immune systems, it can become aware of it. It can develop immunity ahead of time, so it's prepared to immediately fight any infectious agent that has that antigen on it. So it's really quite simple. The immune system recognizes the foreign protein that's injected to the immunization. We mount the immune response. We remember that exposure in perpetuity. Sometimes we need a booster, but we keep these cells and keep that memory of everything we have been exposed to as foreign, so we can fight it off in the future. We have this long-term immunity, so we can respond rapidly if we're exposed in the future. There are some basic ways of giving our bodies advance notice of what these antigens look like. The very first vaccines were the polio vaccine, which was actually a weakened virus. It was actually the virus itself, but it was inactivated, it was weakened, called attenuated, and that was one way to make your body prepared to fight the real thing that we call the wild virus. But there were some side effects that can happen with that, because some of the viruses can cause some mild infection. So we moved away from live viruses to protein vaccines, where it's just the protein themselves that we make in the lab. Making proteins in the lab is very complicated. It's very hard. It's prolonged. It's expensive, but it doesn't have those same side effects. And the shingles vaccine that's out there right now is a good example of protein vaccine, which is very dominant right now. The newer vaccines we're talking about, COVID-19, are a new technique called RNA vaccines. And what they do, go to the next slide. So Pfizer and Moderna are RNA vaccines, and what they do is actually give you an injection of this live RNA. Again, RNA is not the virus. RNA is a bit of code that tells your body how to make the protein. So basically, you're immunizing yourself. We take this RNA into our cells. That RNA lasts for a few days, and in that process, you make these little spike proteins that develop an immune response. So the reason that we do it, or this is now the favored way to do vaccines, is you can make RNA vaccines very quickly, very inexpensively. They're much more stable, and they work really, really well. So basically, we're giving our bodies the instructions on how to create these non-infectious antigens and stimulate an immune response. So the result is that if you get exposed to the coronavirus, you've already have the antibodies available to immediately fight that off. So the result is that your body is attacking the coronavirus instead of the coronavirus attacking you. And the end result is you win. So that's really quick, and hopefully it didn't blow past you too much, but I may refer to some of these concepts when I answer your questions, depending on what those questions are. So I will unshare my screen, I believe.
Great.
Okay, so I'm open for questions.
Wonderful. Thank you, Dr. Maxwell. So I do see Erica Q, you have your hand raised. So if you do have a question, if you could put it in the chat box, we can answer it that way. You can type it anonymously, and we'll just do chats right now, questions in the chat. So there's a question, when will the Johnson & Johnson vaccine become available in Clallam County?
That's a great question. We're asking the same question ourselves. J&J is supposed to, it's the newest one on the market, so there's just not enough national supply. And just so people understand how vaccines are flowing to Clallam, the supplies are national, and there are allocations that come from the federal government, from the manufacturers, to the states in certain proportions. So every state gets only a portion of the supply that's available at any one time. Those go to the State Department of Health, and the State Department of Health then decides which counties get how much of that allotment, and which entities, organizations, or health jurisdictions in those counties get certain amount. So that's a long way of saying that we can't really predict how much will come to the state, much less Clallam County, much less the organization. the best estimate, President Biden made a fairly bold announcement. His goal was that between Pfizer, Moderna, and J&J, that there will be enough vaccine for everybody by the end of May. So they've been working to stimulate the production of vaccine to get it out there more quickly. And so our best guess, there is no J&J, I think it's a small allotment that came to the county health department using for, they had earmarked for, like, I think like 100 doses or something. But as far as wide supply, our best guess is going to be May, is my best guess. But my crystal ball and all that clear.
Great, thank you. Next question. Have people with an overactive immune system or autoimmune disease have a more intense reaction to this vaccine? For example, for example, triggered a flare-up of an autoimmune condition after receiving that vaccine. Is there any reported data for this?
It's a great question, and it does highlight, this immune response that I outlined. That is directed at sort of foreign proteins, but autoimmune diseases is where your immune system is malfunctioning for some reason, where it tends to react against some of your own proteins, and that manifests in different ways in different diseases. We have not seen reported that there's been any decrease in efficacy or increased flares of autoimmune disease with this vaccine. And it's sort of like if you, even though you're activating your immune system, you're reacting it by activating against a specific antigen, a new thing. Just like if we get a cold, if we pick up a cold at school, our immune system is stimulated, but we don't necessarily see a big flare in autoimmune symptomatology. So we've not seen that. Obviously, there's always that theoretical concern is it actively uses to make things worse for me if I have autoimmune disease. We've not seen that. There was a second half of that question.
Is there any reported data, for example, triggered a flare-up of an autoimmune condition after receiving the vaccine?
Yeah, no. So no, there isn't.
Great, thank you. Okay, next question. Can you please address the shellfish allergy concerns? Is Johnson & Johnson a safer choice if we have a severe shellfish allergy?
Great question. So the issue about what you've heard about, and what if you go to get a vaccine, they'll have a series of questions asking about allergies, especially severe allergy, anaphylaxis, where your blood pressure drops, your throat closes up, you can't breathe. So those really severe allergies, it's not that these vaccines are any more likely to cause that. It's simply that if you have a history of that to other things, then theoretically the statistical chances that you might have an overreactive response to any vaccine. And to be honest with you all, that caution was mostly generated by lawyers, not science. I mean, because it has not been out for a long, long time. They're just trying to mitigate their risk by saying, well, people who tend to get allergic to lots of things, well, we don't want them getting this and being allergic to that, because that creates problems for the vaccine. So it's not really vaccine specific, it's more person specific. And what we've seen when we're in the vaccine clinics, we're asking people, we have people come with shellfish allergies or sulfa allergy or any number of different allergies, and all we really do is just observe them longer. We have emergency medical personnel standing by to offer help if needed. But I've been at every one of these clinics and talked to lots of people who said have an allergy like shellfish or others, and they just sit there in a chair and they go home. So we've not seen that. I do have one patient of my own who was a nurse who had a history of lots of allergies to various things. And she did about half an hour or about an hour after she got the vaccine, she said she felt a little bit funny. Maybe she felt a little bit more short of breath. It's really unclear if it wasn't true anaphylaxis, but whether, sometimes our minds can make us really worried and we can have a lot of symptoms. But we have not seen a big preponderance. but obviously be cautious.
Thank you. Next question. Is it recommended for women who are breastfeeding to get vaccinated? And if they are in their childbearing years, is it safe to be vaccinated?
So the first question was that with breastfeeding, it's not recommended, not because it's thought to be harmful, it's just simply that studies have not been done in that population yet. So the general approach is if we don't have the data to tell us, we err on the side of caution and say just don't do it. Over time, I think we will get that authorization for pregnant women or lactating women. We cannot give live virus vaccines because that can be transmitted, through the breast milk and so forth. But just as I outlined, this is not a live virus vaccine. It has this RNA. So in the second half of the question was for childbearing years. No, there's no reason not to get vaccinated if you're just a childbearing years. If you're pregnant, again, that's a different population, so we'd probably recommend against it.
Great, thank you. If you have had cancer, are you at a higher risk of getting sick if exposed?
I missed that first word, comment.
If you have had cancer, are you at a higher risk of getting sick if exposed to COVID?
No.
You mentioned the Pfizer and Moderna as RNA vaccines. What is the Johnson & Johnson considered?
J&J is considered a DNA vaccine. Inside, they're actually taking the DNA and they have a piece of DNA that creates the RNA that generates the spike protein, and they took that put that inside a adenovirus, actually a different virus. So they took some coronavirus information, created DNA out of it, stuck it in a different virus, a cold virus called adenovirus, and they're using that to get inside your cells, which is what adenoviruses do, and that DNA then uses your cell machinery to create the RNA to create the spike protein in the cell. So it's just kind of one step removed, and I know I've had some of my own patients get kind of a little alarmed. You're putting foreign DNA inside me. Is that going to I'm going to carry this around forever? The answer is no. It doesn't integrate into your cell's DNA. It just floats around and does its job and then gets degraded after a few days. But that's the distinction.
Okay, if there are vaccines left over at the end of the day, can anyone wait in line and get a vaccine irregardless of age or residency?
A great question. If you ask us, the answer is yes. If you ask the governor's office, they say no. And there's a political fight going on. We're basically making King County, Nevada, Florida look bad, and that's where the voters are. So they're putting lots of restrictions on what we can do. But the really short answer is no vaccine dose will go wasted. So if there are we drop the usually vials will hold about anywhere from 10 to 12 doses, and if we open the vial and there's only 2 people there who are scheduled to get it, at the last of the day we have 8 doses left, and there's 8 people standing outside the door, they're going to get it. Now, the county has what's called a wait list of people who are technically in priority, basically in authorized phase, that they will try and contact first to come and get it. But if they can't get a hold of them and they're not available, then anybody who's around can get it. I will say that we've been lobbying for educators to be on that list since day one, and they're unfortunately giving out 5 to 8 vaccines a weekend doesn't really get to the population very well. But I hope that answers your question. That if you're around, hang out. There's a chance. There's no promise. But if you're a teacher now, educators are starting this weekend at the clinic I'll be at this weekend. You guys are top of the priority, so you just have to hang out anywhere.
Great, thank you. Next question. Is a person able to get COVID-19 once fully vaccinated, and what would that look like, the severity?
It's a really good question. As you've heard, these vaccines are not 100%. So they're 95%. That means that technically, if 100 people who are vaccinated get exposed to the virus, 5 of them theoretically could get it. If they get it, what the data shows is that if they get it, often they don't know they've got it. It's asymptomatic. And that's one of the reasons why even after you're vaccinated, they recommend that you still wear a mask and distance, just in case you're one of those people who, come in contact with it and carry it and transmit it not knowing. The really important message from all this is the data shows convincingly that no matter what vaccine you get, and no matter how many doses of the vaccine you get, your risk for getting serious illness or dying from COVID goes to 0. People who get vaccinated just don't die. And there's really get sick or hospitalized. And there's a lot of thinking right now that, Israel actually used that data to totally change their strategy. Instead of giving 2 doses of Moderna to one person, they're giving 1 dose to 2 people, because they actually don't really care if you get a little sick, you get a cold. If you're not going to die from it, and your grandma's not going to die from it, is it as important that we get the illness? We just don't care. We just don't want to die, right? And so that's what Israel did. That we haven't quite adopted that approach, but that just underscores that even if you're partially vaccinated, it's better than getting no vaccine.
Great, thank you. Okay, and this next one, I'm gonna probably butcher some words, but is reverse transcriptase, okay, you know what I'm,
yeah.
Okay, used as an adjuvant for the mRNA in these vaccines?
No, clearly that was a science teacher.
I know.
So hopefully he or she doesn't grade me on my presentation. No, it is not.
Okay, and why do mRNA vaccines use relatively new and untested adjuvants compared to the tried and true of the traditional vaccines,
Because it's basically different technology. I mean, adjuvants, which basically stimulate immune response, are how you get for protein versus an RNA piece, which is chemically very different. I'm not a vaccine specialist in the basic science development, so I only assume that there is some either chemical or biologic rationale underlies that, but I don't get too hung up on that because the end result is it works.
And then is the 3-month duration measured after the 2nd dose?
So actually, it's a really good question, because vaccines really only been out for a short, relatively for a short time. So they say, well, we are pretty confident for 90 days. Once you get past 90 days, we'll be studying more and saying, well, actually, maybe it's 180 days or 270 days. We'll know more as the longer the vaccine is out there, just how long they really last. And what we're probably going to see is that, as with most things in biology, there's a lot of person-to-person variability. So you have to really study larger populations for a long period of time to know what's the kind of mean duration of immunity, to really get a sense of it. But right now, we feel fairly confident that it's at least 3 months. And talking to the county health officer, the data she's looking at, they feel pretty confident it's going to go longer. And there's something to keep in mind, is that when we're measuring duration of immunity, it depends on how you actually define that. Is it measurable antibody in your bloodstream, or is it that you don't get sick? Because there's lots of instances where our antibody levels may drop below a certain level that's low, but actually it ramps up very quickly if you're ever exposed to the real thing, and your levels come right back up, so you are functionally immune. So it's kind of a more complex question. It's a good one, but all we know now is at least 90 days, and that's better than nothing, but it's really likely to be much longer. And that's assuming variants don't, it's a whole other issue that doesn't bypass this immunity.
Thank you. If Pfizer and Moderna are working, what is the reason for making the Johnson & Johnson differently? Is it more effective?
Two reasons. It's actually, if you look at one dose of J&J is 75 to 78% effective, whereas Moderna and Pfizer are 95% effective after 2 doses. What's interesting is that the first dose of Moderna or Pfizer is about 75, 78% effective. So the question is it simply just, if we gave someone a second dose of J&J, that it would be just right up there with Moderna and Pfizer? So that's one of the questions, and they're actually doing those studies now. But part of this really is marketing. So if you're trying, as a manufacturer, you're trying to get a foothold in the market, and you've got 2 95% effective vaccines that are 2 doses, there's a subset of the population of the market that says, I'd really like to just have 1 dose. Does that work? And the answer is, as we talked about, yes, 1 dose keeps you from getting really sick in the hospital and dying. So they went ahead and decided, okay, we're going to put this out there. The NIH and CDC have said any vaccine over 50% effective is a home run. And so 75, even though it's less than 95, it's actually a great vaccine. So they said, let's get it out there. I will tell you logistically, as somebody who's trying to give vaccines, I much prefer to have to try and figure out how to give someone 1 vaccine rather than 2 vaccines 3 or 4 weeks apart. And especially if we're trying to get to the wider community, it's just the logistics of doing that is really, really hard. And so I'm looking forward to a 1-dose vaccine for the right populations. And if I had the chance, I would have gotten J&J simply because it works, and I will have to worry about 1 time. And the CDC has said over and over again, the best vaccine you can get is the one you can get. And it doesn't matter which one it is. And so I'm looking forward to J&J getting here, because I'm actually trying to do an outreach to employees in the community and go out to their clinic, go to their place of business and give them a vaccine. It's a heck of a lot easier to do that 1 time and have to figure out how to do it again on a large scale. So it's a long answer to a short question.
Great, thank you. And so this is a follow-up, just clarifying, once fully vaccinated, a person can still be a carrier?
In theory, yes. If you, particularly, we're finding that if you get your first vaccine or your second vaccine, you're not really fully protected, then there is some risk that you can come in contact with the virus, pick it up, and become a carrier for that 14 days and just not know it. It's not likely, especially when prevalence is low, but that's why we recommend, until the community vaccination rates get up, around 70 to 80%, that we do those other measures when we're in a place where we don't know everyone else's vaccine status.
And our science teacher is back. She says,
I'm in trouble now.
A+ on your presentation.
Oh, thank you.
Yeah, and more questions. What is the prediction of antibody-dependent enhancement with this vaccine, since RNA viruses often have ADE effects?
Have a what?
ADE effects, ADE effects.
You may be taxing my knowledge on my ADE. I'm not familiar with that.
Yeah, and if you could, if the question asker, if you could maybe follow up with that, and then do they know how this vaccine might be an issue? What is the prediction of antibody-dependent enhancement with this vaccine, since RNA viruses often have ADE effects? Do they know how this vaccine might be an issue?
You're taxing details beyond my knowledge, so I will not try and buffalo you with a BS answer. I don't know.
Okay, no worries. If we could follow up, if you want to follow up with that question a little bit more, we can try and get that answered later. Next question, can you get the vaccine in your vehicle versus going into the high school if you hate needles and do not want to see others getting a shot? Or is it available through your medical provider?
There's no questions there. Right now, because of limited supplies, it's just, we've been trying to get in our clinic, we just can't get it. We've been asking the state every week now for 3 months, and there's just not supplies to give to us. So we've been, I'll just give a shout out to the Jamestown tribe, who has been able to get access to vaccine through their tribal connections, and have actually gotten additional vaccine that they've shared with the health department in Port Angeles. So kudos to them. So individual providers have to register with the state to get the vaccine. We've not had any success so far. That eventually will change. I can tell you, we will likely be wanting to do the J&J, just to be able to give it what's called inflow. You come in for your high blood pressure visit, and by the way, you can have your coronavirus shot, just like your flu vaccine. So not yet, but hopefully soon. With respect to car versus coming in, in Port Angeles, we've elected to do a walk-in rather than drive-in for a number of logistics reasons. It just is really hard to do. Jamestown has the car thing dialed in, so if that's really an issue, you can see about going there. I think they may relax the rules, especially if you're an educator. I think you can go wherever you want to. If you do happen to come to Port Angeles Clinic, you will not see anybody else get a vaccine. Everything's private, and so you go into a little tent, and it's there's lots of people who don't like needles, and they've all been fine, and we'll walk you through it. And really, it's our vaccines are exceptional, and people go, "Huh, that's it? It's over?" So you won't have to watch anyone else, and you don't have to look at yourself. You look up in the sky, and it'll be over in a flash, and it'll be okay.
Great, thank you. And then, is anyone making a traditional non-mRNA vaccine based on just the spike protein, even though it is more time consuming?
Not to my knowledge. I think they, I don't know that. There's none that are out there right now. I think there were like 20 different worldwide vaccine manufacturers who took different pathways, and the ones that were the most successful were these mRNA or DNA vaccines. Constructing a protein in vitro is tough, and it uses monoclonal technology. It just takes a lot more effort, a lot more expense to get it done. I'm not aware of any that are out there, and certainly none that are licensed in the U.S.
The Johnson & Johnson CEO explained that their testing was done at a time when the variants were in the population. Were the other two tested? Did the other two test theirs previous to that?
Oh, we have a budding epidemiologist amongst your ranks. That's great. It's actually a good point. One of the theories about the differences in efficacy between J&J and Moderna and Pfizer is just based on that very fact, is that Moderna and Pfizer were the first to kind of conduct their trials, and it did it at a time when there was relatively less prevalence in general, and certainly the variants weren't around. Whereas with J&J, there was a higher prevalence, and then there's some thought that some of the variants may have been in those pools. So some really, they are not head-to-head trials in the same time period, so that might account for some of that differential. But again, even I'm not sure the questioner is sort of getting to whether or not these vaccines are effective against the variants or not. That is a cause for concern. So far, there's 3 variants: the B1, the B113, and the Q4, and they are so far they do not appear. They seem more transmissible, but have not eluded the vaccines so far. But we don't want to push our luck, and some of these, they're just not out widely spread enough for us to be able to say with confidence about how these current vaccines are going to work against them. That's really one of the reasons that we're really encouraging people to get vaccinated as soon as possible, because if you're vaccinated, you will not be a reservoir for a new mutation or variant to form. So the more people are vaccinated, the less prevalence of variants going forward.
And we are coming up to 3 o'clock. Are you still good to stay on for? Okay, we got like 4 more questions and then a couple on the email.
Come on, I'm going to interrupt. So the questions that we have now, I think we have 4 or 5 more questions. We'll cap it at that.
Great, thank you, Marty. How did they figure out the 75% efficacy? Was it release of vaccinated into the general public with standard COVID precautions?
It gets down to the methodology, the design of each particular trial, and to be honest with you, I didn't dive in. I didn't look at the exact memorize the methodology. I know that they, in general, their approach is to go into populations around the country, multiple sites in the same communities, and vaccinate a subset of people in that community that are presumably following the same kind of precautions that everyone else is, and in that kind of real life. So if you're kind of alluding to, does the mask or does masking sort of make it appear more effective than it otherwise would be? They're really comparing against the same population who are doing the same thing. So they try to keep it apples to apples. So I think they basically control for that variable.
Thank you. So ADE stands for antibody dependent enhancement, which means the second infection is worse than the initial, like dengue.
Yeah, we've not seen that. No, but it's a true teacher. I'm learning something on this call. Thank you. Yeah.
Okay, and where can I find a full ingredient list of these vaccines and how the ingredients differ between the 3?
You have to just go, probably Google. I'm sure you can get to the their FDA the little vaccine information sheet to see what's in there. I'm not sure what I would do with that information other than know that it works. But yeah, I just hit Google.
Great, thank you. And then, so if we get the vaccine, we are primed to recognize the antigen. But then if we are infected with the real virus, do they know if there is a long-term enhanced antibody reaction that causes extreme inflammation or illness?
No, we've not seen that. Of course, that would be something where you have to see if later on when you have a widespread deployment of the vaccine, if you start seeing things like that. I have not seen that in the trials. It's it's a theory, but we don't tend to see that. I mean, we give vaccines in our clinic for a wide range of things for decades, and something we just don't see. I mean, not with great regularity, but the theory is that could happen in some person sometime at some point, but it's not been particularly a problem with this vaccine.
Great, thank you. And then I guess Google Scholar has the information for all the ingredients in the various vaccines.
Great.
Okay, and then and I think you already answered this, but just to confirm, will we need to get these vaccines every year?
We actually don't know yet. The one thing about, we have got coronaviruses every year. No surprise, especially the teachers on this call, probably get a coronavirus at least once a year through their entire careers. Coronaviruses are a class, and they commonly cause colds and those kinds of things. They can do some mutation, like many viruses. Appears to be not to the extent that the influenza virus, which mutates every year. That's why you have to get a different vaccine every year to protect against it. We haven't seen that with SARS-CoV-2, but it's only that it's novel. It's only been out for a year, and so they're watching that, and it's possible. But I know that with the infrastructure in place for if that happens, they'll be able to pivot to the antigenic structure, and we might need to get a booster, or it might be a combo flu coronavirus booster. We just don't know.
Cool, great, thank you. And then last question, Why do people get sick after the second dose? And is there anything we can do or take before the second dose to alleviate those symptoms?
If because you had your first vaccine, you got a second vaccine, so you have some a little more vigorous immune response in theory to the second one, and some people feel that way. I can tell you, I mean, I've seen lots of people coming through for their second shots and asked about it. I got my second shot. It actually bothered me less than the first shot. And I've had some people had no reaction at all. Others that, that felt coming for a couple of days, but others and everything in between. And when you deal with biologic systems, everyone's response is a little bit unique, as far as how vigorous that response will be and how they experience that response. It's, even those who got the worst of it, it's just, if you feel achy and a little bit headachy, as I said, all you teachers, you already know what that's like. If you've got students in your room so the past, through your careers. So, as far as what you can do, there's nothing you can do to prevent it. It's not recommended to take ibuprofen or Tylenol beforehand, to prophylax against it or prevent it. But certainly after 24 hours, taking it would be fine. But I've watched my colleagues who felt a little bit crummy afterwards. They missed a day of work. Some just came to work. They're fine.
Thank you. Well, that is it for questions for you. As she said, we had a last comment. Thank you to all involved and to Dr. Maxwell for taking this time. Very informative. And yes, we will have a recorded version. You can email Jenny or myself, and we can send it out to you. So thank you so much.
And again, Dr. Maxwell, thank you so much for spending, nearly an hour with us. We appreciate it. You've been a champion in the community with regards to, the North Olympic Healthcare Network and your commitment to carrying out this important work. So thank you again for your commitment to our school and our community. It's much appreciated.
My pleasure. Anytime.
All right.
Take care.
Thanks, everybody.
Bye.
Good luck, everyone. Thank you.
Good afternoon. Bye-bye.